Hi all, and welcome to this screencast where we're going to be having a look at task 4 from our fourth lab. So this task is all about forecasting the future of stock market performance. So it's a notoriously difficult task. We're going to give it a go though. And the method that we're going to be using is called double exponential smoothing. But before we get to the details of the method, I wanted to take a step back and talk about time series forecasting a little bit more broadly, because this is probably a new concept for most. So I'm going to just switch over to my other screen now, where I've got a couple of short slides prepared to go through this. So what is time series forecasting? Time series forecasting overall is about predicting what's going to happen next based on what has previously happened. So I've got some examples of data where this might be applied. So we've got stock markets, like we'll be looking at in this lab task, where we've got, years and years of data, and we're using that to predict what it'll be on the next day or maybe the next few days. Then we've got things like temperature, which are a bit less volatile than stocks, but they tend to follow sort of seasonal patterns, long-term trends, and we can use that information to then predict what's going to happen next for our temperature. Another one is things like energy usage. So this is energy usage for cans, and you can see again, it has some sort of patterns throughout the year, as well as a general level and some trends that we could use to forecast a day or a few days into the future, or actually this is in months. So that's what time series forecasting is. There's quite a few methods for doing it. The simplest one is to just extend the line. So you could do something like fit a straight line or an exponential line to it and see where that line would take you next. So in this example with linear forecasting, that wouldn't be very accurate for stocks because you can see that it's a long way off the actual value for most days. More complicated method, but still not too complicated, is a moving average, where you average however many values at a time and you use that to predict what's going to happen next. You can see that this fits pretty well, but it's the orange line, which is our forecast, is always slightly lagging behind the blue line, which in the context of something like stock market investment is not a good thing, because we want to predict when the fall is going to happen, not just see it after it has already happened. So that brings us to more complicated methods like the one we're looking at today. The one we're looking at today, I mentioned, was double exponential smoothing. And this method, as well as other methods in this kind of family, are aimed at combining complex patterns. So they might look at a few things, like they might, in the case of double exponential smoothing, look at the general level and the general trend. So overall, the last one, the one we're going to focus on, is better at considering both the longer and shorter term trends of the data so that we can make a better guess at the future. You can see that it actually is sort of staying with the blue line rather than lagging below it. The others have their place, but in the context of this, it's not really going to give us an accurate look at what tomorrow's stock market prices will be. So we'll dive a little bit deeper into double exponential smoothing now. We'll go through all the math in a second. I'll get you started on writing the code for this task as well. But first, I wanted to give you just some intuition as to what the pieces mean. So double exponential smoothing includes two components, essentially. It considers both a level and a trend. So level is where we are now. It's a smoothed estimate based on recent observations as to what we would generally expect the level of our data to be. Trend then tells us how quickly the level is changing. So again, based on recent observations, was it trending up or was it trending down? How quickly was that change occurring? So for things like daily temperatures in a particular area, the level and trend would tend to change pretty slowly. Like level would be reasonably flat for a particular area, and trend would only be sort of gradually drifting over many, many years. For data like our stock markets, which are a lot more volatile, the level and trend can change quite rapidly and noisily. And you can see that in these graphs here. The level has fluctuated a lot over the 25 odd years that I've included in this data. And the trend changes quite dramatically week on week, and by quite different magnitudes as well. So the way that we use these two things is we take today's level and today's trend, and we add them together, and that gives us tomorrow's forecast. So when we're forecasting, we always remain one time step ahead of the observed data. So it's a little bit difficult to see in this plot because there's 25 years of data here, but if you look really, really closely, you can see that the orange starts just after the blue. So it starts after we've had 2 weeks of data, and then it keeps going into the future. staying 1 week ahead in its forecast, which means that we can then use that information to make a slightly more educated guess about whether we should buy or sell our stocks. Though I wouldn't really recommend using this very simple method for financial purposes. So beyond double exponential smoothing, there are also a lot of options for more complicated data. So in our assignment, we're going to be using a method called the Holt-Winters method, which also captures seasonal trend. So data like our minimum temperature and our energy usage in cans both showed seasonal variations across the course of the year. Temperature goes up in summer, so does energy usage because we're all wanting to run our aircons up here. So Holt-Winters takes level and trend, and it also adds in this extra parameter of seasonality explicitly. We can even go to even more advanced methods beyond that are outside of the scope of this subject, but are interesting anyway, like artificial intelligence. And where they are really useful is that they can handle even more complex patterns, both within the data itself, and also take into account other parameters that might be related to the one we're interested in. So for example, we might predict temperature using both temperature information as well as other things like the cloud cover, the rainfall, the humidity, any other parameters that might contribute towards that heat. Similarly, with stock market levels, we could predict what's going to happen in the Australian stock market based on markets in the US, in Asia, in Europe, as well as other economic indices or global events. So that's something that can only really be captured with something that can handle those multiple streams of data. Anyway, that's the overview of how time series forecasting works and all of the sort of options that are out there. But for today, we're focusing on just our double exponential smoothing. So I'll pop back over to our task sheet. And what we've got is, actually, I might just share my whole screen at this point so that we can go through both MATLAB and the task sheet. So what we've got is some starter code that I'll show you in a second. And we want to use that template to develop a rolling forecast where we're continuously plotting 1 day in advance, or sorry, 1 week in advance to guess what the next stock market level is going to be. And then at the end, we also want to see what the error was between our method and the actual what happened in reality that week later. So there's our level and trend parameters, which are called S and B in this method. Not sure why they've decided on those letters, but they have. The first thing we need to do is initialize them. So we actually need to use up a little chunk of our data from the start to initialize those parameters. So we use our very first observation to get our level, and we use the difference between our first 2 observations to get our trend. From times beyond that, so starting at week 3, we can then update those parameters as new data comes to light. So we're continuously updating our knowledge, continuously revising our understanding of level and trend, and that also allows us to continuously revise and improve our forecasting. You'll also notice in these that there are parameters of alpha and beta. Those are smoothing factors. So there's some defaults given in the task sheet. You're welcome to tweak them, but they control how responsive it is to new versus old data. So a heavier weighting, a higher level of alpha would lead to, or actually for both of them, would lead to more weight on recent observations and therefore a more responsive forecast. Lower weightings would be the opposite. So it's a trade-off as to the sort of data you're working with as to whether that's going to be useful or not. Then the last piece of the puzzle is the forecast itself. So again, at each time step, we're forecasting 1 week in advance. So we would have our current level plus this parameter M for number of weeks ahead multiplied by our current trend. M in our case is always going to be 1 because we're only looking 1 week in advance. You could, if you wanted to as an extension, go beyond that, but that's not within the scope of the task itself. Cool. So let's jump over now to our MATLAB script. Just close this one. So in MATLAB, you've been given the template that looks like this. So the first thing it does is it loads the Excel file. So you need to make sure that this template is saved in the same folder as that Excel database. And then it extracts just the ASX 200 data. So at this point, we're focusing just on the one stock market. Again, as an extension, you could go beyond that and add more, but for now, we're just going to look at one. That's all you have to do for this task. Alpha and beta have been set. You can tweak as you want, and the forecast window has been set to m equals 1. Again, you could change that if you wanted to look at something more advanced in the future. So the first thing we need to do is our initialization. So if we jump back over to those equations that we had, the first one, initializing our level, is just going to be setting it to the first observed data point. So what we can do is we can get our level and let it equal the first observation in our data. And that's it for the level. Then if we have a look at trend, it's the difference between the first and the second. So that means that our trend is going to be the difference between second observed ASX data and the first observed data. You'll also notice the slight difference in indexing. So in the algorithm, time equals 0 is denoted with a 0. MATLAB indexing, though, starts at 1. So it's 1 and 2 minus 1 rather than 0 and 1 minus 0. But it means the same thing. With those in place, the next step, if we read our steps down here, is to perform the first forecast for 1 week in advance. So we can take these two things, create our first forecast as level plus m times trend. And again, m is always going to be 1, so really we could just leave that out as well. Either way is fine, whatever makes sense to you. So that's our initialization done, and we could then plot it to see what is actually happening. So if we plot, firstly, our observed data, actually, I should also make a note, this forecast 1 is going to be a forecast for the third day. So we've used up days 1 and 2 in initializing, which means our first forecast is actually for the third, I should say, week. So it'll be for week 3 rather than anything earlier. So when I plot this, what I'm going to want to do is I'm going to plot the data that's actually happened. So I'm going to plot the first 2 observed data from the ASX. I'll plot that in blue. And then I also want to plot the forecast, which starts at time point 3, at week 3. And I'll plot that one in red with the star. And yeah, I'll leave the rest for later. I'll add some stuff to that soon. So when we plot just that, we can see actually blue's not the greatest color with the dark mode. Let's go yellow. So we can see that we've got our observed data that goes up to here. Based on that, we're predicting a value tomorrow that looks like this, or next week that looks like this. So that's our initialization done. Now we're into this next part of the algorithm where we're going to be using a loop to step through all weeks of data. Within that loop, we're going to be updating using our 2 update equations and then creating a new forecast and then updating our plot. So we'll start off with these update parameters, and what I'm going to do is I'm just going to do it for 1 week. So I'm not going to put it in a loop for you. That's going to be a task for you to figure out in the prac, but we'll go through how these update equations can be implemented in code. So our first one is our level update. So our level update includes alpha times our most recent observation plus 1 minus alpha multiplied by our previous level and our previous trend. The other thing to note is that we need to make a copy of our level before we destroy it because we're about to have to use it down here as well. So actually, let's do this bit first, then I'll come back to that. So we'll have alpha multiplied by our latest observation. So we're now observing day 3 plus 1 minus alpha, and then we're using yesterday's level and trend. So level plus trend. We can just replace those entirely because we don't need to keep them. And make sure I put my multiplication sign in there. So that's our level update. Then our trend update uses beta multiplied by the difference between our 2 levels, so the most recent level and the one before that, and then also takes into account the trend before that. So this is where I was saying we'll actually need to create a copy of level before we destroy it. So I'll create that copy there. And then when I update my trend, I'll have beta times our level minus our level old plus 1 minus beta times our previous trend. So we don't need to create copies of trend because we're not replacing it until we're finished using it, if that makes sense. So that's to do our update equations. And then the next thing we would want to do is we would want to actually go through and do our forecast, and then we would want to plot it. So we're now forecasting for day 4. So our second forecast value will be for the 4th week. So level plus m times trend. Again, m being 1, you could leave it off. And then we want to update them. So we can pretty much just copy this plotting code from before, and I'm just going to modify it slightly because we now want to plot the first 3 days of observed data, and we want to plot the 2 days of forecast data. So another thing I'm going to add to the plotting here, just to make it a little bit easier for us to see this as a rolling thing, is I'm going to get it to draw now, which means it'll draw immediately before running the next step of code. And just to be able to visualize that a little bit slower, I'm going to put in a pause. Don't do this at home. It's really inefficient. This is just for visualization. So we'll do that at both of our plotting steps. So I'll pop that same code down here as well. So let's run this. And we can now see that we've got our 3 days of observed data there, and we've got our 2 days of forecast data. So at this point, we could now also figure out what the error was on week 3, but we've still remained 1 week ahead as we forecast into week 4. So we could then do this a few more times. This is super dodgy code. Obviously, you want to do this in a loop, but for now, I'm just going to copy and paste it a couple of times so that we can see this process repeating. So again, our update equations for the next day, we would just increase our index. So now we'd be looking at the 4th observation. We would be generating our 3rd plot for the 5th week. Then we would be plotting 4 days of observed data and 3 days of forecast data, and so on and so forth. So we'd be increasing this index to 5. Then we'd be increasing this index to 4, all the way through all of the other indices as well. So that's all of them done. Like I said, don't do that at home. You want to put that into a for loop instead and consider how you're going to actually use indexing with that for loop to do that change rather than manually copying and pasting it for the like 52 by 25 data points that you've got. Before I run this as well, I'm just going to add some code at the top to clear any of those variables so that we don't end up plotting the wrong version of forecast or whatever else. So to clear your workspace, you can just use the clear command. And then if you've got any figures that you want to close up, you can also use the close all command to close those, which will clean that up as well. So if I now run this, you can see that it runs through and it stays 1 day ahead of each one. And it follows, I must have accidentally run that twice. And it follows the forecast. So the observed data is always 1 day behind, 1 week behind the forecast data in this case. And you can see that they're not too bad like their stock markets, so it's not super accurate. Like I said, don't use this as an investment strategy, but you can then calculate the error as well by finding out the difference between the forecast and observed points. So that's getting started. What's your task now? Your task is to actually take that further and complete the full task. So I'm going to get rid of all of this really rubbish code that I just wrote by copying and pasting, because like I said, that is not the way you want to do it at home. You also don't want to be using pauses, so you can get rid of those now as well. But your next steps are going to firstly include turning that into a for loop. So use a for loop to repeatedly update level and trend and produce the next forecast and update the animated plot. So all of that stuff that we've done here should go into a loop. You'll just need to think about how you index it. Where do you start, given that we're starting with week 3? Where are you going to end? All of that sort of thing. So that's the first thing you're going to want to do after you've completed this video. The other thing you would want to do is potentially consider how you could make the plotting more efficient. So at the moment, we're recreating the plot every single time from scratch, but that's not the nicest way to do it, particularly when you've got a lot of data. It can look really, really slow. So something you could consider instead is update the plot rather than recreating it every single time. That's something you only really need to consider once you've got it working, though. You can always go back and tweak that afterwards. Thirdly, you need to go and actually calculate the error. So between the forecast and observed data. You need to be careful about considering the indices because, again, that forecast is always one day ahead. You don't want to accidentally compare these two because that wouldn't be right. You want to compare the forecast for week 6 to the actual recorded value for week 6. So you need to be careful with your indexing here. And then lastly, you would like to, well, you might like to consider going further. So the extension task suggests that you could then do this for more of the data. So if we have a look at our full stock market data, we've got the ASX, which is the one that we're focusing on, but there's also the Dow Jones and the Nikkei. So you could extend your solution to include these extras. The reason that that might be beneficial is because that is very similar to what you have to do for your assignment. So for your assignment, you have to consider 3 parameters. So you could extend your solution by also including the other 2 stock markets. And the way that you'd want to consider doing that is by using vectorization, as well as looking into subplotting. So that'll allow you to do sort of 3 plots on one axis type thing. So that's what you need to do next. Hopefully you found this video helpful, both in terms of understanding time series forecasting as a whole and in getting started with this lab task. From here, it's mainly just that step 1 that you need to do to have completed it, as well as that mean absolute error calculation. Everything else is just about making your code better and better. More work you put into this one, though, the easier it's going to be when you step up to the assignment, which follows a very similar approach, and there'll be a separate video on that one as well. So I'll probably see you in that video.